Good morning, everyone. I hope you are able to hear me and see my screen. Can someone respond if you are able to hear me? Yeah, I could not be able to speak louder, guys. So I have a little cough. I'll not be able to speak louder. Okay, let's continue. So today, yesterday we have looked at tree map and tree set. So what is the internal data structure of a tree map? What is the internal data structure of a tree map?
Node?
Yeah, it's a node only. What happens when I call the put method? What's the difference between a put method implementation of a hash map and put method implementation of a tree map?
Okay, put method implementation of hash map is it is a linear, and tree map is a BST, right? Binary. It has a left and right.
Yes.
Thing to
So
bypass.
yeah. So first, first the thing happens is whatever the given key, we calculate the hash code and then calculate the index, and then at that index we'll store the node object. But apart from that, in the tree map internally it uses a comparator. If we do not pass any comparator, it uses whatever the generics that you are passing. That generic should implement a comparable interface. If not, whenever you are running, you will get a runtime exception. So it will go to that comparator or comparable compare to method. Based on that, it will identify if the value returned by the comparable is less than 0, that element will be inserted at left side. If it is greater than 0, that will be inserted towards right side. So it forms a tree. But in the link, in the normal hash map, before 1.8, it does not form a tree. It forms a linked list approach. But there is a performance issue. In order to overcome that, we go for a tree approach. Am I right?
Yeah, from Java 1.8 onwards, it's a tree.
Yeah. So what is a tree set? What is the internal data structure for a tree set? What is the internal data structure for a hash set? What is the internal data structure for hash set? Anyone? You can type or speak. Hash map, right? Do you guys remember?
Yeah.
So for tree set, it's a tree map.
Yeah.
Is the hash map ordered?
No.
Is the tree map ordered?
Yes.
Ordered by what?
Natural.
I mean, in that map, we have key and value. So will it be ordered by key or value object?
Key.
Key object. How does the tree map ensure that it orders the natural sorting order of key? How does it will do? What is the internal implementation? It uses a comparator, correct? See, whenever you are adding a data, is it storing the insertion order? No. Whenever you add a data, what is happen? It will go to the comparator, correct? Compare method, and then it checks. That means it will store the data on the logic that you have implemented for a compare method. If you are writing a natural sorting order, it will do the same thing. If you are writing a descending order, it will do the same thing, correct? Internally, tree map is using a comparator, whereas hash map does not use a comparator, correct?
Yeah, it is -1, 1, and +1, depending
Yeah,
upon that.
logic, whatever you are writing. Yeah. So, and the leftover topic is interview questions and queue implementation using stack. So let us do that now. So let me write here queue. So what does the meaning of, what does the queue follows, guys? What does the queue follow? What's the pattern?
First in, first out.
First in, first out.
Okay. Now that means if I am using, so that means any data structure which is following a first in, first out, I can call it as a queue. Am I right?
Yep.
And so that means internally, so I'm following a queue means I can store the data in the form of array, in the form of a linked list, in the form of a tag, whatever you can store, as long as whatever you enter the first element, and whenever you're trying to delete element, the first element is coming out, then that is called as a queue. So what we are doing here, see, we already looked at queue using an array, correct? Yes or no? Queue
Yeah.
implementation using an array. We also looked at queue implementation using a linked list, correct? If it's an array, I have used an object array data type structure. If it's a queue using linked list, then can I say I'm using a data structure called as a node?
Yeah.
So now if I'm saying that queue implementation using stack, then what should I use, guys?
Stack.
So I have to use a stack data structure, correct? Stack. So I'm storing an object internally instead of integer or something. I am putting a this one equal to new stack. Let me keep it as a outside variable, and then I'm initializing. Now, can I say that I'm initializing this variable in a constructor? Yes. Now, so here whenever first of all, I want to add a data to the data structure. Now, I'm implementing a queue using a stack means my internal data structure is stack. So, so if I say queue equal to new queue, and first of all, I want to write some method to add the data, correct? Say public void add object obj. Now, whenever, see, this is my user defined method add. So in order to add a data, q dot add method, and I'm passing 10. Now where this 10 should go, guys? Which data, in which data structure I'm storing this 10?
Yeah, just store it in stack.
Yeah. So how can, so that means in the add method, see here, this is my user defined method. It's not a add method. Let us make it as an insert. So this insert is nothing but my user defined method. So in insert method, what should I write the code? I have to add the data to the stack. How can I add the
Yeah.
data to a stack? What is the method to add a data to a stack object?
So the
S
add or
dot,
put.
yeah,
Add.
add method or push method, correct? So whenever so here, if I'm calling 10 times, now can I say I'm adding the data to a stack object now, correct?
Yes.
Now here, see, what is the insert method? This is just one class. Using this class, I am implementing a queue using a stack. So that's the reason I'm using it in default data structure called as a stack. Now, whenever you're adding a data, my internal data structure, I'm telling it as a stack. So I'm adding the data to a stack. Done. After that, so I should also create one more method for delete, correct? Or poll. Now, generally, if this is the data is present in your queue, if I say first in, first out, which element should come out? Or if I say q dot poll, and inside that
10.
So if I say poll, if this is the data, then you should get 10, correct?
Yeah.
Again, if I call again, what is the output here? Second time?
20, 30, 40.
Okay, after that, if I call now, after deleting 40 also, if the queue is empty, do you get exception or will it,
Yeah, you get exception.
is it exception or null?
Null will it.
Yeah.
Null.
If it's a stack is empty, then can you call the pop method or push method on an empty stack? We'll get an empty stack exception. Reason for that is whenever you're doing a pop, if your queue stack size is 5, if I'm deleting pop, my size will become 4, correct? So if your stack is empty, your size is 0, and if you allow, then your size will become -1, which is not allowed. That's the reason empty stack exception is thrown. Now, here currently, this poll is nothing but a user-defined method only, correct? It is this poll is not a method of a queue, correct? It's method of a user-defined. Okay. Now, can I say, see, generally stack means see, the internal data structure here is stack. Now, if I say in a stack, I have a method called a pop. If I call the pop method, what will be the output? On this data, if I call a pop method, what is the output? Assume that there is a stack. See, whenever you're calling this q dot insert, where the data is going? When I call this method, where the data, what is the flow?
First in, first out, it will sit on the first.
No, don't worry. Let's tell me. Can I say this is a class?
Yes.
Is this a class? Yes. And what I'm doing? Q is an object. I'm calling the insert method. So from here, can I say it will come here?
Yes, definitely.
And if I call 4 times means you are adding the data to S. S is nothing but stack. Can I say how the data will be present in a stack now?
10, 20.
10, 20, 30, 40. Now, this is a stack object, correct? Now, but how can I say that see now I can say that I'm implementing a stack using a queue. Sorry, I'm implementing a queue using a stack. That means I have stored the data in a stack. Can I say 50% of the work is done? Queue implementation using stack means where do you want to store the data? Inside a stack only. Am I right? If I say queue implementation using array, what is the internal data structure?
Object array.
Queue implementation using linked list. What is the internal data structure?
Node.
Now, similarly, queue implementation using stack. That means what is the internal data structure? Stack. So whenever you call the insert method, am I storing all the data in the stack object? Is it correct?
Yes.
Okay. So that means we are done with the storing. Now, when can I call it as a queue, guys? Any data structure, when can you call it as a queue?
You follow first in, first out.
Yeah. Now, in this one, this is a stack object. In the stack object, if I say pop, what is the output of stack? If I say pop, what element it will give?
10.
See, this is a stack object.
Last in, first out. It will
That means, can I say it will give 40? Correct? This pop method output is what? 40, correct? Yeah. But if I return 40, is it following a first in, first out?
No.
From the poll method, see, or else instead of poll, let's call as a remove method. This is one user-defined method called remove. Now, in the remove method functionality should be the internal data structure, the data is stored in a stack. Now, I have to write a remove method functionality in such a way that it should give me the first in, first out. But if I write h dot pop, what is the output of h dot pop? Can I say 40?
Yeah.
Okay. And if I return object, return, will it work? Is it, if I write this code, is it working like a queue?
Yes.
Okay, again. Okay. Now here I am calling the data for insert method 4 times. It is inserting the data 10, 20, 30, 40. Now if I call the remove method, now it is coming here. In the remove method, what are you doing? H dot pop. What is the output of H dot pop, guys? In this scenario? Are you not following me?
40 it will first time it will be 40.
It will, can I say it, S dot pop means stack will return top of the stack. So that means it will return 40. And can I say, if I do sys out, what is the output here? Q dot remove means
40.
40. But here, is the 40 first inserted element for you?
No, no, sir.
It's a last inserted element, correct? That means, can I say it is not following a first in, first out, correct? Current remove method, is it following a first in, first out?
No.
No. Agree with me, everyone? Or shall I explain again till this point? Asif, do you understand or shall I explain?
Got it.
Okay. So that what I meant by that is, see, in an insert method, I'm using a stack and adding the data. Similarly, in a remove method, if I'm just using a pop method, will it behave like a queue? No. That means, can I say I have to modify? See, insert method is fine. I'm adding the data. Can I say now I have to modify some code inside a remove method and return 10 only. So whenever I call 13th line number, what is the output you are expecting in order to become a queue?
It has to be 10 first in, first out.
10. What is the output from a line number 14? You will expect
40 now.
20.
20.
Line number 14, correct? And line number 15?
30.
30, correct? If I am doing that, can I say that I am following a queue?
Yes.
Yes or no? Now so that means I can, so whatever I am doing here in a queue, in a remove method, whatever I am doing, that is not the right approach, correct? Now let us write the code. I have to write the code here. Now, in a queue, if you're calling a empty, if you're calling, remove method or poll method in an empty queue, it returns null. So I am checking first. The internal data structure is stack. Stack dot is empty. If it is empty, then what should I return? Return null. Okay. If it is not empty, what I have to do? I have to first I am taking s dot pop. S dot pop will give me the object obj. Now I have to arrange the data in such a way that in the remove method, I have to pop and arrange the data in such a way that it will give me the first in, first out. In order to do that, what I'm doing, if s dot is empty, if it is not equal to empty, I'll continuously call the pop method. That means I'll call the same remove method here, the same. Say it's a recursive method. Now, whenever it is removing, I'll put obj. Let us see. Let me tell you what is the code. Okay, let's remove the else. Okay, now so look at let us understand. Now whenever I call the insert method, the data is stored like this. Okay, now first I am calling line number 13. Let's do the manual debug. When first time I am calling line number 13 remove method, it comes here. Now is your stack empty, guys? Is it true or false?
False.
False, correct. Then line number 28. What is a s dot pop? What is the output? What does obj will contain?
40.
40. Done. Now is the stack empty?
No,
No.
After deleting this object also, is it empty?
no.
No. Now again I'm calling the same method again. So here, can I say it's a recursive call? Let us write the algorithm, correct? Let us take three. Okay, let us take 4 elements, then fine. Now first, let me copy this. First, you are calling remove method. In the remove method, is the stack is empty? No. First, you are calling s dot pop. S dot pop means what it will give? Let me show you the code here also. Both are fine. S dot pop means in our example, we'll get S dot pop means what is the output we get? 40, correct? Okay. Then after that, is it empty? No. If S dot is empty. Is it true? Not equal to empty. See, here is empty method will return true if it is empty. Okay. Now here after deleting 40, now my data structure is before calling the remove method, my data structure is containing 10, 20, 30, 40. But whenever I call the pop method, 40 is deleted. And what is the data structure left out? Can I say 10, 20, 30? Agree? Guys, please say yes or no. Yeah, 10, 20, 30. Now, is the stack empty? Now, just whatever I have highlighted. What does the is empty method will return? It will return true if the stack is empty. If it will return false if the stack is not empty. In this scenario, my stack is containing 10, 20, 30. So is empty method will return false. Not equal to false, true. Again, I am going into this method. Now, if you look at here, can I say I have to execute this same number of lines? And then here after this else block, I have to write return. What is the item? Item is nothing but this 40. Done. Okay. Now here, if you look at guys, can I say from this, so this is a DQ method is nothing but it's a remove method. Now I'm calling the same method again. Now whenever I call the same method, now my data structure at this time, my data structure will be this one, correct? Yeah. Now can I say it is a recursive call? I will call the same method. Done. Now here, what is the internal implementation of this remove method? First, it is checking is stack empty? No. Okay, and then they are popping it up. Stack dot pop. What do you get? 30, correct? 30 equal to s dot pop. Okay, done. Now, once that is done, what is the next? Is stack empty? No. Let me copy this one. Is the stack is empty? No. No. After 30 is removed, what is your data structure, guys? Can I say 10, 20 only?
20.
Yes.
10, 20.
Yeah. Okay. Now you did not do here. You see, here, what is the meaning of item? Here, what is the meaning of item? Item is nothing but this object name. It's a temp variable. So this 30, you are adding this 30
But
here.
30 is
Correct?
that.
You're adding
Okay.
30 here, correct?
Yeah.
And then your item equal to tempo means this will become 30, correct? I hope you are following me. Okay. Now again, I'm calling the same method. Let's copy these 3 lines of code. That means I am rearranging the data in such a way that, see here, my data structure when at this point of time is 10, 20. Now here, whenever I say item, this tag dot push is nothing but I'm pushing 30. Sorry, here it is 40 because outer loop. It's an inner loop, right? See, it's an inner loop. Here, this item. Okay. And here, so this 30 will be passed here. Okay. Now, whenever I say DQ or remove method again, okay. Again, I'm calling that remove method. Now, what does the remove method is doing? Is the stack empty? No. Now, what I'm doing here, stack.pop, s.pop. What does I will get? From 10, 20 data structure. What if I do pop? I will get 20, correct?
20.
And what is the remaining data structure? 10. So here it will return 20 equal to, correct? Done. Now, can I, is it a stack is empty now? No, still it is not empty, correct? S dot is empty. We'll do the Eclipse debug also, don't worry. Again. Instead of this, you can write even while loop also, doesn't matter. Now I will, these 3 lines of code will execute again. Okay. Now when it is executing, again, same thing. So here, whenever you say item, so what is stack dot push? That means you are pushing this 20. 20. Okay. Now you are calling the same method, remove method. Okay. Now here, whenever you call, before calling the remove method, your data structure is containing 10. So first, what are you doing? What are you doing here? S dot pop. S dot pop will give you, can I say 10? And your data structure will become empty. Correct? Agree with me?
Yes.
Yeah. Now after 10, is stack is empty now? After I do pop, is it empty?
Yes.
Now
Yeah.
can I say this loop, see, is empty method will return true, not equal to true, false. Can I say this loop will be broken?
Yeah.
Whenever this loop is breaking, what is the item that you are returning? Whatever is stack dot pop. That means the inner method will return 10, correct? So this 10 will be written and this 10 will be pushed to here, correct? Sorry, my mistake. So the 10 will be pushed here because see, after this, see, this computation is nothing but whatever is returned by this inner method. Now, after this computation is done, the 10, 20, see, this item is nothing but 20. 20 will be pushed here. And after that, 30 will be pushed. And at the end, in the down, return 40. This 40 will be pushed. So that means you are rearranging the data in the stack that 10, 20, 30, 40. Now, whenever you return it, 10 will be returned. Now, let us do this. Let me debug so that you will understand. Let us debug from starting. Debug as Java application. We are inserting the data. Okay, 4 times we inserted, done. Now I'm calling the remove first time. So look at here, is my stack empty? No, 10, 20, 30, 40. Correct, done. Whenever I say s dot pop, what is the object will contain? 40. And what is my stack will contain? 10, 20, 30. Is it correct from the algorithm? See, 10, 20, 30. Am I right? Yes, no?
Yes.
Now, so is it empty? No, it will go inside. So can I say from here, I'm calling the same method again? From line number 30, the same method will be called, but these 2 lines of code will be there later point of time. Am I right?
Yes, later.
Later point of time, these 2 lines of code will be there. That means, see, after this line, there will be these 2 lines of code, correct? Okay. So now, whenever I call the remove method again, I'm going here. So whenever you do remove, see here, first time the obj value is 40. Am I right? First time. Look at here. First time obj value is 40. Let's write. First time whenever this is called, obj value is 40. Done. Now from this line, it is calling the same method. Now what is your data structure? 10, 20, 30. Now if you call the pop method, what is the second time output of pop method? Object 30, correct? And your data structure is 10, 20. See, second time, I will say second time 30. Can I say here, your data structure is 10, 20, 30. After doing pop, your data structure is 10, 20. Look at here. Is it same? 10, 20? Yes, no? Yeah. Now again, you are calling the same method, correct? Now, whenever you call the same method, third time it will go. From this S 10, 20, if you call the pop, can I say third time you will get the obj as 30? So 20. Third time it will give you 20. Now here, look at here. After 10, 20, what is your data structure? It is 10, correct? Look at here. If I say s dot pop, see, my object will contain 20. Now, my data structure is 10. Here, this is the one, right? Now, again, I have to call the same method. Fourth time, what you will get? Fourth time, you will get 10. Done. Now, after calling the fourth time, after doing the pop, see, object is becoming 10, correct? Done. Can I say your data structure is empty now? Yes or no?
Yes.
Now, whenever it is empty, can I say I'm at this loop now? See, after remove, whenever I call the remove method 10, when I say s dot pop, 10 is the output. And my data structure is empty. Can I say whenever I'm debugging, I'm into this loop at this point of time? Agree with me, everyone? Please respond.
Yeah.
Okay. Now is this condition true or false?
False.
False. Whenever it's false, can I say it will not be further called? That means I'm breaking the method, correct? I'm not calling the method again. So it will come out. And what it will return? Obj. What is the value of obj? 10, correct?
Yeah.
Now, so can I say this is the output of this line number? Yes or no? Is this the output of this line number or not?
Yes.
If from the remove method you called and this has broken and it is returning, so that means can I say my temp will hold 10?
Yes.
And object will hold some other value. That means after this line, these 2 line numbers should be executing, correct? Yes or no?
Yes.
Yeah, now let us see. See here, obj value is nothing but 10, correct? So you are returning 10. See, you are returning 10. Now, if you look at here, from this line, it will go to the s dot push. See, it will come out. See, now what is the value? See, okay, it is returning. The first method has written 10. Why did the 20 has come up? Because here, see, from this remove method, whenever it is broken, it has written 10. But before that, there is another method also. Look at here. This method, what is the output of this method? Hope you understand what I am trying to say.
It returns 20.
Yeah. So that 20 is getting added. Look at here. I have written wrong there, but look at here. See, 20 is getting added. Now again, again it will go back. Look at here. See, 20. After that, can I say once it is broken the loop, it will come here. Look at here. See, it is coming the previous one. What is the value second time? Look at here. I have written here 30. Now, again. So now what is the value? Well, first time I deleted 40. So now look at here 40. Okay. Now if I come back, now here, now you look at the stack data structure. Okay, sorry. What is the output I got? From the remove method, what is the output I got?
10.
Now, what is the in my data structure? What is the first inserted element?
10.
And what is the first deleted element?
10.
Is it following a first in, first out?
Yes.
Yep.
Now, let us do again. That means every time whenever you are calling the data, what I'm doing, I'm arranging the data in such a way that it is following a first in, first out. Correct? Hope you get it.
Yeah, this is achieved
Yeah.
through the
Recursion.
recursion only, right? Yeah.
Yes. So the problem here is, whenever you're calling this method, you need to understand how the flow is executing. Hope you get it.
Yeah, we got it.
Any questions, anyone? This is little tricky to understand, but we know
Yeah,
how
it is.
does
Yeah,
recursion algorithm
yeah, it
works.
is kind of tricky, but I forgot how we implemented stack using queue. Did we use recursion or something else?
No, we did not use. We just added because the queue is different, right?
Okay.
So stack, we have added the pop method, push and pop. So that is the reason I'm asking to look at the code or practice.
Yeah, I think by practice only we'll get it, but
Yes. So you every time you are polling and then adding, polling and adding.
We remember this. We remember this.
Here also
Yeah.
you can write a recursive. Wantedly, I have explained one with a recursion, one with a. See, whenever you are writing a recursion, can't you write with a for loop? Yes, you can write.
Yeah.
So here, wantedly, I have explained one with a for loop. See, the same kind of a for loop logic you can write here also instead of recursion. But in the interview, they might be asking implement the same. See, what is a for loop? Doing the same work multiple times, correct? What is a recursion? Same. Whatever you want to execute, you want to execute multiple times, correct?
Yeah. Got it.
So recursion also you can do with a for loop. Now here, whatever you are doing with a queue stack implementation using queue, the same thing you can do here also. See here, for I equal to 0, I less than stack dot size minus 1, I plus plus. You add it to the stack and you take it from the stack and then return that element at the end. You can do that also, not a problem. But that would be easy, already you know. So since we have learned we implemented this stack using queue before the tree topic, correct? Now, whenever I was explaining the tree topic, I have explained what is a recursion algorithm. That's the reason I have taken this queue implementation using stack at the end to explain you guys the little tough topic of a recursion.
Yeah, got it. Thank you.
Any questions, anyone? Sunil, Raj, Harish, Asif, does it understood or shall I explain again?
No, understood, sir.
You just need to play with it. I mean, you need to write the loops and all and then execute it. Okay. Now, let us see what we have done. Now, this is a course content I have shown you guys during the class. I mean, during the demo classes. Let's see whether we have covered all the collection workshop details or not. Did we talk about need for collection? What is the need for collections?
Yes, sir.
Okay. You can tell me honestly, there is no, like if we discuss, say yes. If we don't discuss, I mean, like even if you miss the class, you might not be knowing. Say no. No issues. Even if we are not discussing, I will take, see, don't think that today is the last day. We'll take a weekend class or some other way we can cover it. So I just wanted to iterate whether we have covered everything or not. Okay, collection hierarchy. Did we discuss? When I say collection hierarchy, parent is iterable, and then collection. From there, list, set, and from there, array list, vector. So did we discuss that hierarchy?
Yes, sir.
Collection versus collections. It's an interface and it's a
Class.
class. And we
Yes.
have seen some methods also, right?
Yes, sir.
Internal implementation of a list.
Yes.
I mean, array list. Okay. Internal implementation of a set.
Yes, I shall.
Internal implementation of map.
Yes.
How to create a custom collection. I mean, custom vector,
Implementation.
custom array list. Correct?
Yes.
Yeah. In the list, did we discuss about array list properties, custom, how to create a custom array list, and what is the add method implementation, what is the get method, remove method, contains method of array list, vector and linked list.
Yes.
Yeah. And we also discussed about why the array, what is the meaning of synchronization, correct? Specifically, array list is not synchronized, vector is synchronized. If you remember, I have written two threads programming and I have shown you guys, right?
Yes, sir.
Yeah. So did we discuss the hash set, linked hash set? We did not. Okay, I'll come to that. Now, hash set we discussed, copy and write array set. Why do we
Yes.
go for this copy and write array set? To overcome the
Concurrent modification exception.
exception. So linked hash set, we did not discuss. It's only the difference is it's a ordered. Generally, hash set is not ordered. Linked hash set is ordered. We'll discuss this. Don't worry. Now, hash map we discussed or not? Linked hash map we did not. Let's keep it as a star. We have discussed about something on a linked hash map while doing sorting of a hash map, correct? Sort the hash map by keys, sort the hash map by values. At the end, I told some of the interviewers might ask you that I have given you the map, given me the map.
Yeah,
give
yeah.
the
The
map
last
again.
for loop you did it. The last for loop.
Yeah. So, but anyways, I'll explain. Only the difference between a hash map and linked hash map is linked hash map follows insertion order. Internally, it will use a linked list, like some approach. Okay, we'll discuss. Don't worry. Now, concurrent hash map. Concurrent hash map. Why do we use a concurrent hash map?
Let's say.
And another one, concurrent modification exception. Correct. See, if in a list, in order to overcome the concurrent modification exception, we go for a copy and write array list. In a set, copy and write array set. In a map, we don't have a copy and write array map.
Yeah, yeah.
Concurrent
I
hash
think we
map.
discussed.
Concurrent hash.
We discussed this.
Yeah, how to sort the hash map by values?
Yeah, we discussed.
How to sort the hash map by keys?
Yes.
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 We discussed various approaches, correct?
Yes.
Why to override equals in hash code method in a hash map?
Yes. Yes.
So to find the unique combination, correct? Hash map allows unique key. Key cannot be duplicated. If you are duplicating, the value will be overridden. How does the hash map identify that you are providing a duplicate key? By calling the override and by calling the equals and hash code method, it will identify. Okay. Now, what is a iterator and how we can use a iterator? During the concurrent hash map, I call that there is a iterator method. And there is a list iterator method also, correct?
Yes.
List iterator method is having
Forward and backward extra.
previous method, but normal iterator is having next method.
Yes.
Yeah. Collection iteration. Look at here, guys. In the collection iteration class, I think I have explained. So whenever you want any program, guys, go to file, search with a just name. I want to see what is a class that I have created for iterator. Look in here. Collection iteration. Now here, look at here. I've used a L dot iterator, L dot list iterator. I have also explained with a generics also, correct? How can I get it? So it has a previous method, has previous, has next, like that. Okay. Can I mark it as yes?
Yes.
Yeah. Did we see the difference between a iterator and list iterator?
Yes.
What is that?
Listed iterator have a previous methods, like previous and
Use,
forward.
yeah.
13
Using iterator, you can
previous
go
and
next only, but using list iterator, you can go previous also. What is a concurrent modification exception and how to resolve it? Did we see this?
yes.
What is the internal logic?
Mod count will be there.
Yes,
Based on the
there is
mod
one
count.
variable called mod count. It gets incremented every time whenever you add a data to a collection object. It can be a array list, it can be a vector, it can be a hash set, it can be a hash map. So, but whenever you call the iterator, there is an expected mod count. In a next method or previous method, they are checking if the mod count is not equal to the expected mod count, they throw the exception, correct? I have written this in the notes as well. Am I right?
Yes.
Yeah. Okay. Now, concurrency versus synchronization. Did I tell about this? I have drawn some diagrams. Synchronization means one thread is accessing one object, it will lock on the entire object. Concurrency means it will lock the on thread level, correct? Segment level. Segment level, right? Let us see somewhere. Yeah, look at here. See, there is a diagram. So vector, it's synchronized. That means it will acquire the lock on an entire object. If you look at a copy on write array, it will acquire the lock on a segment level, correct? Hope you remember this one, this diagram. This we discussed on 6/28. Are you able to remember? Yes, no? Yeah. You can, if you want, you can go to the recordings and then go to the 6/28. Okay. Copy and write array list, copy and write array list, concurrent hash map. We have modified it, right? How to create a custom collection? It's a repetitive question. Then in the linked list, can I say insert head, tail, middle? That means inserting a node at head position, tail position, tail is nothing but the last, and middle position. Did we see? Inserting a head, inserting one node at before the head, middle,
Yes.
or at the last. Did we see this?
Yes, yes.
Yeah, these are the questions regarding that. Okay, the same thing will be there. Did we discuss deleting a node from a linked list before the head, middle, or last?
Yes.
Yeah, we have created a custom linked list. In the custom linked list, we have created some remove method, correct? See, this will take care of a node deleting at first position. This is anything in the middle. This is last, correct? We have written in one line, one method, sorry. Now, how to print a linked list? Did we see this? Printing a linked list. See, toString method. In toString method, what are you doing? You are iterating over the linked list data and then printing the object, correct? See, toString method is returning a string object. In the string object, you will say open bracket, all the data in the data structure, and then close bracket. Am I right?
Yes.
I can't hear you. Can someone?
Yes, sir.
Yeah. So did we see about what is a stack? Basic stack properties, push, pop, peek.
Yes.
Okay.
Yes.
So it's the same stack problem only. I mean, in the hacker rank, whatever we have done in the class, that is there in here. Stack implementation using array. Did we look at it?
Yes.
So let's go to the stack package. Custom stack using an array, correct? Look at here. Custom stack using an array. Now done. Now stack implementation using a linked list. Can I say we did discuss custom stack using a linked list? Yes, no.
Yes, sir.
Yeah. Stack implementation using queue.
Yeah.
Correct? Yeah. Now coming to the queue. What is a queue? Have we discussed?
Yeah.
Basic properties of a queue. Peak, pole, push.
Yes, copy.
What is a DQ, blocking queue, priority queue?
Yeah.
Okay. What are the
DQ is
differences between? Yeah. Sorry.
DQ is for adding and removing from end and last, first and
Yeah.
last.
Yeah. Double-ended queue. That means you can do the operations in both the end. Blocking queue, I have explained using one program, correct? I mean, producer consumer problem. Specifically, blocking queue operation will be provided by put method, right? And take method. Now, priority queue internally uses a comparator. It follows the natural sorting order. What are the differences between linked blocking queue versus array blocking queue? If your linked blocking queue follows linked list approach, array blocking queue follows array approach. Linked blocking queue, we have seen there is one constructor. Do you remember? If I don't enter the data, the size of a linked blocking queue will be integer max value. And here we do not have a constructor. We have to enter the data. Do you remember that? Let me show you. If you look at here, while I was discussing this producer consumer problem, I have explained. Look at here. If I remove this element, can I say array blocking queue is showing a compilation error? That means you need to declare the size of array blocking queue. If you and linked blocking queue, if you do not pass any size, what is the pre-default size? Can I say integer max value? Correct? Integer max value means what? 2147483647. That means your array internally, this many number of elements can be stored. And the linked list, so linked blocking queue follows internally. It's a queue. Queue you can implement using any data structure. Linked blocking queue follows similarly node kind of a structure. See, look at here. Am I right? Here, do you see like this means head, tail in what? That means head and last will be there in what data structure? In linked list only. Am I right? Guys, can you say yes, no, so that I will know?
Yes, Karthik.
Yeah, please. So I'll not be able to speak much. I'm having throat infection. So that's the reason I'm requesting you to please. If you're not agree with me, say no, no issues, but just a response I need. Okay. So if you are using an array blocking queue, see if you are using an array blocking queue, this dot capacity, that means internally you are using a array. Look at here. Array blocking queue, it's a constructor. In that, what are you doing? New object array. That means the implementation is a array kind of a thing, correct? Yeah. Now, did we discuss queue implementation using an array?
Yes.
Let's go to the queue package. See, queue implementation using array. Queue implementation using linked list. Queue implementation using stack. Today we discussed, correct?
Yes.
These are the three things. And coming to the tree, basic concept. What is a binary tree? What is a binary search tree, etc. Right? And how to create a tree. For tree, there is no predefined class in Java, but we discuss about how to create a tree, correct? How to create a binary normal tree.
And binary
Tree.
search.
Yeah. Now, if you look at tree implementation, see like this left child, right child, I have done. But if you are creating a binary search tree, we have written an add method, correct? Yeah. See, and after that, can I say, did I write the algorithm for in-order traversal? In-order and post-order I have written. And I have asked you guys to write the pre-order, correct?
Yes.
Yeah. And look at the program also we have written. See, in-order, pre-order, post-order. I have explained writing the algorithm with the in-order and then post-order. Let's see that algorithm also. Let's, if it is. I'll share that also with you, but I'm just showing. See, recursive algorithm. See, look at here, in order, correct? See, let us see, look at here. This is a post order, correct? So we have written the algorithm for both, and I have asked you to explain one. And did we discuss about a tree set? Tree set, tree map, did we discuss?
Yeah.
Yeah.
Yes,
So inside the tree map, we use a comparator. Look at here. And I have explained using a comparator or with by default what happens. And I also explained how to sort a hash map, we know, without the tree. But hash map object, you can pass it to the tree map so that it will be sorted by keys, because internally it uses a comparator, and comparator goes to your generic key object comparable interface. Okay. So we did not discuss only these two, linked hash map, linked hash set. I will explain that. So this coming Saturday or Sunday, so from tomorrow, the advanced data structure topics are going to start. So this linked hash set and linked hash map, I will explain on the weekend, either 29 or 30, based on my availability. I will let you know, guys. Okay. And we also need to discuss about the interview questions. I'll show you the interview question that I have written. I thought of discussing today, but because of the time, I could not. We'll discuss that also on the weekend. Yeah. I've written a data structure interview questions like this. So I'll be sharing this document with you also. So these are the things. This is also one thing we have to discuss. All these questions. Okay. So this also we'll do on a weekend. I mean, whenever we are having a class on the weekend, we are going to discuss all of this. Okay. So it also has a questions on the data structures, but except the data structures, whatever the collection questions we are going to discuss. So there is one more class on the weekend. We are going to discuss about the linked asset, linked hash map, interview questions, and then we can close this class. Yeah. Linked hash set and linked hash map. Does anybody wanted to add anything?
Sir, will interviewer ask how to, custom hash map, how to do custom hash map or a hash set?
I have not seen, but even if they are asking, the custom hash map internally uses a linked list, correct?
Yeah.
Only the linked list, you have to store it in some index only, right?
Mm.
So I haven't seen them asking, but even if they are asking, you can do it, right?
Yeah. Yes.
So from tomorrow, the advanced data structure topics is going on. I have seen some people like in the initial they'd ask, first I would like to enroll for collections, later I will enroll for data structures. So from tomorrow you can attend the classes, and if you are interested, you can enroll it. And from tomorrow, I'm going to start these topics. Okay.
Sir, do we discuss identity hash map and weak hash map?
Those will be there here in the advanced data structures.
Okay.
Yeah. Those are part of this one.
Okay. Okay.
Yeah. Anything else?
And so one more, sir, will you start a core Java batch? Any recent?
I have not started. I don't know how, because nowadays full stack batches are getting started, right? I don't know how many people will be turned up only for core
Okay.
Java.
Your core batch, sir. Actually, I
Yeah,
want.
yes, that is true. But I don't know how many people will turn up for the core Java. So that's the reason I'm not yet starting. Because even now the importance of core Java, so you wanted to join. But outside the people, Java means they'll take it light, correct? And they're offering the full stack, Java full stack courses, correct?
Yeah,
So full stack also will be in that full stack, the core Java is also part of it.
profit, right?
Yeah. So they will join for that. So very one or two people will be turned up for the core Java. So that's the reason it would be difficult for me to explain only for one or two people. Or even if it's a bunch of people, then I do get interest, right? And different questions will be asked by different people.
Yeah.
So what we can do is we'll keep a demo sessions maybe after a month, and if good number of enrollments are happening, then we can continue. If not, I can stop it.
Okay. Okay.
Yeah.
And sir, if any query, I mean, any questions, if I want to ask you, how we have to connect with you?
So the Telegram group, sorry, WhatsApp group is
WhatsApp
there,
group
right?
is there for all the time.
Yeah. It will not be deleted. It will be stays active. You can put your question in that,
Okay.
and based on my availability, I'll provide you the answer.
Right.
Okay.
Yeah.
What about others? Any question?
Sir, actually, he's telling that we'll start that MongoDB.
Yes. So there are many things are coming. So that's the reason I'm starting one by one slowly. For MongoDB, right? No one has taught till now. So I have to I'm preparing a good material like whatever I have done for this collections, threads, core Java, data structures, etc. So the material preparation is in progress. Once that is done, I'll start.
Okay.
Any other? So if no question, that's all for today. And join the demo classes from tomorrow and understand. And if you are interested, enroll for the advanced data structures. If you like the way I teach, inform your friends. And there will be one more class. I'll put it in the Telegram. That will be a last class of the collections batch. Okay.
Yes, sir.
Yeah.
Okay. Thank you.
Yeah. Thank you, guys. I'll put a feedback
Thank you.
link in the WhatsApp group. I request all you to please provide your feedback. See, put your honest feedback. I don't mind. Even everyone will have a ways to improvement, right? I request you guys to please provide your honest feedback. Okay.
Sure.
Yeah. Thank you, guys.